An important aspect of the visualization challenge is being able to either find or build computational models of the important small molecules or proteins related to your topic for use in Jmol images. And so in this webcast, I wanted to talk a little bit about the common data sources that you can use to find molecules in computational form, and how you can use the Jmol interface that we provided to build your own molecules and work with those. So for the first half of this webcast, I wanted to begin with talking about data sources for protein structures specifically. The example I've chosen for this webcast is carbonate dehydratase, which is also known as carbonic acid anhydrase. And this is an enzyme with a massive amount of information available on it. And so an important point associated with finding computational models is realizing how to actually pull out the models from all of the other information that's available on this page. The easiest way to do this, in my experience, is simply to just Control or Command F for the words PDB or Protein Databank. If we do that on the carbonic acid anhydrase page, what you can see is that only 2 hits emerge, and these are just 2 links to the same table that list the PDB codes associated with this enzyme class. From here you can download the PDB file directly. However, what will be more useful for you is to actually view the PDB entry on the PDB website itself. And so an alternative to using a database like Brenda or Keg is just to go directly to the Protein Databank, which can be beneficial if you know the PDB code that you're looking for in advance. So I'm just going to go ahead and navigate to one of the PDB structures here. The information that you can get from the PDB website itself is often extremely beneficial. So every entry includes the abstract of the paper with which the structure is associated. I almost always read this in case it contains some interesting information about the structure itself. Below that, the ligand section is very useful. It can tell you which small molecules are bound to the protein in the active site or elsewhere. And then finally, the other link that I commonly use is the View in Jmol link, which allows you to look at the secondary structure of the protein and the small molecule ligands in ball and stick form, as you can see here. It should be noted that the views that you see on the Protein Databank are typically missing the level of detail that we're interested in, namely bonds and atoms, the specific amino acid side chains, and their roles and mechanisms, right? And so the structures that you see in the Protein Databank are going to require some processing by you in order to be suitable for visualization challenges. And the way that we modify these structures is by using the Jmol interface that we've developed. And so the easiest way actually to plug in a Protein Databank structure into your Jmol Interface account is just to head to the interface and use the File PDB Entry dialog to just pull up the entry based on PDB code. So this pulls it up from the web, so there's no need to save the structure to your local computer or to your desktop. Instead, you'll work with it and modify it in the Jmol interface, and the file that you'll save will get saved on the web as well, so you'll always have the opportunity to access it, and working offline should never be necessary. So we can simply paste in that PDB code 2W3in from the structure that we looked at previously and press enter and wait, and the structure will load. It comes in to the Jmol interface in bonds and atoms form automatically. So some things you can do to clean this up: under Tools, Common Tasks, hide any waters associated with the protein. Often water molecules will be along for the ride in these crystal structures. And then you can cartoon the protein to show the secondary structure, even doing something like coloring the cartoon by the secondary structure as well. And so now we have the protein in a form that looks very similar to what we saw in the Protein Databank. Once you've styled the protein to your liking, the next step is to save this to the Jmol Interfaces server. If you don't do this, then every time you load the PDB back, you'll get the same standard ball and stick formatting that we got when we loaded the protein the first time. And so you want to save your styling information for sure, because the particular bonds and atoms that you want to focus on will be important for your visualization. So the way to save your files is to use the File My Files panel. At the top you see a list of any files that you've saved in the past up here. And what we'll be interested in here is the Save Window Contents area. If you have a file that's on your desktop that you'd like to upload, you can use the uploader, but right now we have a file in Jmol that we'd like to save, and so we can give this a name like 2w3in pretty. There's no need to add any extension or anything like that, just letters, numbers, and dashes, and then a quick description about what's in the Jmol window to help you remember what's actually in there, and you'll see that description appear up here in this list. So after clicking Save Jmol File, you'll see the file appear in your list, and you can access it later just by clicking its name in the list up here. It's also possible to build a molecule, usually a small molecule, for use in Jmol using the Build Molecule button that you find at the top of the interface up here. And the way this is done is pretty straightforward with a couple of changes from the PDB approach, and so I'll go through an example really quickly. Let's say we were interested in building phenol. We could build it in the JME applet over here thusly, and then to get it into Jmol, all you have to do is click Load into Jmol. The software will automatically minimize it for you, which is why you might see the molecule jiggling or moving around a little bit. But once you've got the small molecule in there, you could do all kinds of things with this, add curved arrows, molecular orbitals, whatever the goal of your visualization in particular is. And the way to save this is just a little bit different from the way you would save a PDB file. Head to save.jmol, and this is going to ask you to save a local copy to your computer, and so we could name this something like phenol.jmol and hit save. And now the way to get this into your list of files on the server is to head to your files panel and use the uploader section. And so add a short description here, click upload file, and you'll be prompted with a drop down where you can choose that file from your computer. And you'll see a dialog appear that says that your file has been successfully uploaded. You'll see it appear in the Jmol window, and you'll see it appear in your list of files, like so.